So what I would like to do is, has anyone heard of FizzBuzz? All right.
Yeah, that's
Jess,
where you.
I saw your hand first.
I've seen this problem before. It's usually you are going to print out, you're going to iterate through a line of sequential numbers usually starting at 1, so 1, 2, 3, 4, 5, and then you print out the numbers one at a time, but every time you hit something that's divisible by 3, you write fizz instead of the number. So it would be 1, 2 fizz, 4, 5 fizz. Well, and then every time you get to something that's divisible by 5, you would write buzz, and if it's divisible by both or 15, then you write FizzBuzz instead of the number.
Okay. Yeah. So that is FizzBuzz. It's a classic. I actually got asked to do FizzBuzz in an interview once, so it does happen. So let's solve FizzBuzz. I'm gonna cross my arms and just sit here.
So I guess we start with a for loop.
When you write the function, or is the function already written?
We have what you see on the page, which is, so we have a blank document right now.
Okay, so let's do a function with a parameter for the maximum number.
And this will be like, so I would give this function, 10, and it would print out from 1 to 10.
Right.
Okay.
Would you start with a for loop?
Yeah, you do a for loop. That sounds good. So how are you thinking that the for loop fits into this, Deb?
For let I
mean, not the details, but just from a slightly larger perspective. I mean, how do you, what purpose is the for loop serving?
I guess to loop through the it's gonna, I'm assuming it's gonna loop through the numbers, I guess, loop through the information, and then loop through, I guess, whatever number is input.
So by information, so we're passing in one parameter here, which is going to be a number. So let's say 10. So what are we doing with our for loop?
So I guess it's going to start with like, I'm assuming it's going to be start with like let I equals 1.
Okay.
And then if I is less than or equal, then
so just tell me like
the number.
Okay. Yeah. Okay.
And then increment it.
Okay. So you want to iterate once for every integer between 1 and
10.
The number that's passed in.
Or the whatever number's passed in.
Okay. So that sounds good. So that'll allow us to do something for every integer, right?
Yes.
Okay, so I'll write that for loop.
Would this be an else statement? Because else if it's 3 or else 5, or an if statement, for if? Or...
Yeah, so that's a good thought. Let's, before we move on to that part, so I'll come back to that in a second. Let's, I mean, how do we know that what we have works or is doing anything?
Can we just put I into an array to build an array of numbers?
We could build an array of numbers.
Okay.
How do we know? How do I know that I wrote this for loop correctly?
We can console log I.
Okay. So it's usually a good idea to do some kind of incremental testing to make sure that what you're doing is sensible. So you don't write 30 lines of code and then at the end you realize that none of it works. So how do I run?
You need to call the function FizzBuzz with some parameter or some, not parameter, what's the other word?
Argument.
Value?
An argument.
Okay. So FizzBuzz. And we'll just do, well, yeah, let's do 10. That's fine. So how do I run the file?
Is it console.log, the function?
Is it node test or npm test?
Node fizzbuzz.js.
Oh, no.
Yeah. Yeah, so node and then the file. So we want to run. So if we were in the browser, then we wouldn't need node. But here we're on our computer on the command line. So we need node to do stuff with JavaScript. So node, and the name of the file. And then we get 1 through 10. So that looks good, right? So this is a good, you can kind of like stop here and we've got a piece of what we need, right? We can now iterate over everything. And now we need to do something with all of these, right? So, yeah, Cindy, did you have some ideas about?
Well, I was thinking it's else. I'm not sure if it's else or an if, but if it's else divided by 3 would equal fizz, else divided by 5 be buzz, and else divided by both would be 15. Is that how you would?
Yeah, so yes, I think that's good. We'll need to have some conditionals. We'll need to test for those 3 things. So let's go ahead and let's write those out. So you said 3 and then 5 and then 15.
Yes.
Okay. So and how do I check?
And Jed, why was it if instead of else? I wasn't sure. So why is it if instead of else?
You can't start with else. So you need, if you want to use else, you need an if first.
Okay,
You
perfect.
can use if without else, but you can't use else without if.
Okay. So if I is divisible by 3,
Yeah, so is
Modulus.
okay,
good.
good.
Put it modulus, or is it going to be the slash for division? Because you don't want any leftovers, right?
So we want to check if this is divisible by a given number.
You
So-
can divide anything by a number, but you would want to get something that doesn't have anything in the decimal, or
So you would add the 3 equal signs and then a 0? The compared, I guess the strictly, what is it? The
Okay.
3 equal signs and 0?
Uh-huh.
If I is divisible by, you got to add the 3 after the divisible. Yeah.
Okay, so someone tell me what this is actually doing. So
So when you
It's going to show if the remainder is 0.
exactly. So this is it's like division, but it only cares about the remainder. So it only gives you the remainder. So if there's no remainder when you divide something by 3, then you know that it's divisible by 3, right? So
Okay.
9 divided by 3 is going to be 3 with no remainder. So we know that it's divisible by 3. Okay, so what should we do in this case?
Would it be if else or else if now? Else if the same thing,
Right, so-
modulus 5.
But before we move on to the next conditional, what should we do if this condition is true?
Should we console.log FizzBuzz or?
Yeah, console.log fizz.
Okay. So let's go ahead and should we just keep writing more code, do you think?
No, it's
We
10.
should have if we're going to do this before or run it before doing the 5 for Buzz, then we should at least do an else for so that if something happens that's not a 3, then it'll console log something.
Okay, so yeah, that is a good point. I can comment back in this console log, so every integer will show up, and if this works, then we should see 1, 2, 3 fizz, 4, 5, 6 fizz, right?
That works too.
So yeah, so one idea that I would like to introduce is doing, testing frequently and in small, like the smallest possible chunks. Right? So 1, 2, 3 fizz, 4, 5, 6 fizz. So this is what we expected, right? So we wrote a small piece of code and then we tested it. We had an expectation, we tested it, and it worked. All right, so now let's write another condition. So I heard if it's divisible by 5.
So else if.
Okay. So I do the same thing. So it's divisible by 0, and we'll console.log buzz. And now we have this piece of code. So this should be good, and we'll test that. So we get 1, 2, 3 fizz, 4, 5 buzz, 6 fizz, and so on. So we have the buzzes where we expect them. We have the fizzes where we expect them. All right, and then we have one more condition, which is
If it doesn't meet any of those two,
Could it be another else if with ampersands? So
oh,
else if the first I modulus 3 ampersand I modulus 5.
So we'll run into an issue.
So what issue is that?
So it won't reach the condition for if the number is divisible by 3 and divisible by 5 if it runs into one of the earlier conditions first.
So let's take 15, for example. So Greg, can you walk me through what happens when I do 15?
Yeah, so when it reaches 15, it'll, our first conditional, it'll be divisible by 3. So it'll console log fizz. Then the else if won't run, and then our third conditional won't run in that iteration of the loop. So instead of writing FizzBuzz, we'll end up with fizz.
So what we need to do is add a not or an and. So I modulus 3 equals 0, and I modulus 5 does not equal 0.
Okay, we could try doing that. So I think that will work. So there's a couple. So let's think about all the things we need to do. So if it's divided by, divisible by 3, we print fizz. If it's divisible by 5, we print buzz. If it's divisible by 3 and 5, we print FizzBuzz. If it's not divisible by any of those things, then we print the number itself. So we actually have 4 different cases. So
I think what Jenny's suggesting would work, and another way to do it would be to add that the code with the ampersands instead above the first if statement that we have. So change, if you put it in above it and then change that divisible by 3 one to an else if.
Okay, so add another conditional here.
Right. So first you could first check it to 15, and if it wasn't divisible by 15, then check it on 3 and check it on 5.
Okay, so we could do if it's divisible by 15, or we could also do, as Jenny was suggesting, I divisible by 3 and I divisible by 5. So either one will work. Then we will console We'll change this to an else if. Okay, so let's see if that works. Okay, it looks like so our previous stuff still works. So fizz still goes on 3, buzz still goes on 5. When we get to 15, it's only FizzBuzz. So it looks like this works. So we have one final thing we need to print out. Just I'm going to comment out this initial console log just to see what it looks like. So we've got all the fizzes and buzzes and FizzBuzzes, but we need the numbers.
So would it be another else statement that has console log.i?
Okay. So we get 1, 2 fizz for buzz. Fizz is 6. That makes sense. 7, 8 fizz buzz, and then 15 is fizz buzz. So this looks like it works to me.
We did it, yay.
Does anyone disagree or see any issues here?
Yeah, I have a question with doing the I modulus 3. But one gentleman said that if we did that and put the ampersand, if it hit the 3, it would automatically default to the 3. But if you have the ampersand, don't both pieces have to be correct before I can go to the next line?
So yeah, so that was in relation to the 15. So if it's divisible by 3 and 5. So this condition could be written differently. So we could do, I modulus 15, or we could do I modulus 3 and I modulus 5.
It just has to go first. Okay.
Yeah. Okay. So we've done some testing, right? We did some console logs and so on, but how do I really know that this is gonna work? Would you want to just throw this into production if there were millions of dollars at stake? I mean, it seems to work.
You could test it with an array of values. So you can do like a negative value, edge cases. So you could like put a string in there. You could put all kinds of funky stuff in there and see if it breaks.
Yeah, okay. So one important thing to consider is checking inputs and maybe error handling and things like that. So that is very important if you want to have a serious some serious code. But even if we assume, which we shouldn't, but even if we assume that our input is going to be a nice number between 1 and whatever the biggest number JavaScript can handle. Also, let's say that I wrote this code and then I move on to a new job, and 5 years later some other guy comes on board and maybe they want to add some bit of functionality or do something here, or there's a problem, someone notices that there's a bug. How does anyone know that this works? Is everyone just supposed to do some like a few console logs here?
So we tested it, right? I mean, we did the node test.
We did well we didn't do we didn't test with node, right? So this is not an npm project right now, so running npm test, for example, wouldn't do anything, but we did like test it, right? As we were developing it, we ran some tests and we're pretty sure that it works. So is this as sure as we can be that it works?
No.
Yeah. Yeah. So we can be a little bit sure, and we can also document our sureness so that other people can be as sure as we are. So writing tests, if you know, I know some of you have done software engineering. Jim, do you have any experience writing tests?
Not like really verbose ones, but kind of like what we did in the challenges on Thursday, where you write a file that, you know, will pass in the values and test what you expect to see from the function.
Yeah. Yeah, so testing, so doing kind of like, you know, smaller, maybe ad hoc tests for unit tests, even for specific bits of functionality. Do you enjoy writing tests?
No.
Is that your favorite part?
No, I mean,
writing
it's
code?
necessary, yeah. And then obviously, like, you do user testing eventually, like get a group of potential users to try it out, and then they'll do things that you as, you know, the programmer didn't expect, and then you'll find even more bugs that way.
Right. Yeah. So testing comes in lots of different flavors. It's usually something that people tack on to the end after they've already, you know, I already, you know, developed this. Oh, wait, I got to write a couple tests. Okay, so let me just knock out a couple tests. Probably just confirming what I've already done, not necessarily that robust. And then you ship it off. And if something breaks, then you come back later and fix it. And that's fine, but there are better ways to do this. And, you know, for professional grade code, you're going to want lots of tests that are robust and that actually document your code. So I'm going to talk about something called test-driven development. So this is a methodology. It's, you know, it's one particular approach to writing code. And we're going to at least learn how it works. Whether you implement it all the time is up to you, but we will definitely spend some time learning how this works. And the basic idea is that, so most people will intuitively write code the way that we wrote code, right? There's a problem I want to solve, so I'm going to start writing code, and I'm going to do some checks, you know, as I'm writing it maybe, and then run a couple different, pass a couple different parameters in and just kind of see that it works. So that's kind of like naive testing. It's still testing, but it's usually write the stuff first and then write the tests after that. So test-driven development flips this intuitive process on its head and says, no, you write tests first and then you write code. So it will feel, so we'll look at an example. It will feel strange at first. It will feel unnecessary and bizarre, and you're welcome to have that view. That's fine. I kind of have that view myself. But the idea is that you use your tests to do a couple things. It's not just something you tack on at the end. It's documentation. So your tests, someone who looks at your code after you can look at your tests and see what the code does. It's like specs. So, okay, here's what the code is supposed to do here. So it can do this, it can do that, it can do this. So I can read your tests and understand what your code does, maybe even better than if I read your code directly. So one, it's documentation. Two, it creates a stable basis from which to change your code later. So code is constantly being, it's not like I wrote my code and that's it, right? It's constantly being modified, changed. You add a feature, you remove a feature, you update something, you fix a bug, whatever. So code is constantly, it's always a living thing. So if you don't have a set of tests explicitly written, when you make a change, then it's like you're starting from the beginning. So if we went over to this, and let's say we wanted to, add another thing. So when the number, I don't know, 13 or something that was divisible by 13 shows up, we add something else. So if we were to make a change, we're basically starting from the beginning. So we don't have a whole bunch of tests already written. We need to make sure that our old functionality still works, right? So we don't have that assurance that this change that we're introducing is not breaking stuff that was working before. So having a robust set of unit tests, you can be confident that any changes you're making are not going to be breaking other things. So the way this works is you will start by writing a test, and you'll start by writing a test, and that test should fail, right? So this process is kind of abbreviated as red, green, refactor. So red is a failing test. So you write a test that should describe some small piece of what your code does. So you might start with something like, this function exists, or this function returns a string, or whatever. So you start with that, and then once you have your unit test, you run it, and it should fail because you haven't written the function yet, or your function doesn't return a string. So once that test fails, you're on the red. Then what you do is you switch from your test and you go to your code, and you write just enough code that the test you just wrote passes. So if my test is this function should return a string, then you go into your code and you just write return empty string or something like that. So it sounds a little silly at first, but that's the process. So then you write your function and you just return an empty string, and you run your test again, and it should pass. And then you can take a look at your code. Is there anything else that I can, refactor or so on? Then you start again. Okay, what's the next thing that this function should do? Well, if I give it a 1, it should return fizz or whatever. So then you write a test, you run the test should fail. And then you go and you write code, just enough code to make that test pass. And then you just keep going through that cycle over and over and over and over and over again. So every little bit of code that you have has a unit test. So by the time you're done writing this function or whatever, this unit of the application, you should have a whole bunch of unit tests that, one, document what your code does and what it should do. Two, that give you confidence that anything else you add or change, you'll know immediately if it's breaking other things. So you can be confident making changes to things if you have a robust unit test suite. Are there any questions about that? We will go through
it in this platform. You have to do it in agile.
So this is not really connected to agile necessarily. This is just an approach to programming. So it's part of, there's a like a school of programming called extreme programming. You do. You can read up on extreme programming, but it's a software development discipline that organizes people to produce higher quality software more productively, and so on. So one part of extreme programming is this test-driven development, where you kind of invert the normal order you would do things. So you can read up on that if you like, but we're not going to take everything from extreme programming. We're just focusing on this one thing. Part of it is an exercise and getting you to realize that tests are important. So you don't have to subscribe to this particular methodology, but whatever your methodology, you have to write tests. Period. That's just how it is. So just as an experiment today, we'll try doing it this way. So I'm gonna go ahead and let's say we will go through an example, and we're gonna redo FizzBuzz, but we're gonna do it in a test-driven development way, and we'll see that our code will probably look a little different than what we have. So test-driven development, yeah.
I just want to clarify the term refactor. It says there it just means eliminate redundancies. Is there anything else we should know about that term?
It just means like, yeah, so just clean things up, making sure that it's basically like I wrote my small piece, and it's kind of like double checking, look at the whole thing. Does this whole thing work together? Is there some, is there some way I could make this more efficient, or is there a different data structure I could use, or whatever? It just means go back and look at everything again.
So if an application has a release to production and then like bugs show up on a regular basis, could that be an indication that that development team doesn't have a very robust test framework they're using?
Yeah, for sure. So you can't expect to eliminate all bugs, and there are different kinds of testing. So we're concerned about unit testing, which is the lowest level of testing. There are also other levels of testing. There's integration testing. So you could potentially have several different levels, but if you think of, you have unit testing, which is basically like I have a function and I'm testing my function. Then you have integration testing, which could mean a couple different things, but basically do all of my functions, or does everything in this component work together properly? So you're not just individual elements, but does everything cooperate and work together? And then you also have like end-to-end testing, which is testing the entire system. So I think the basic schema is there are three levels of testing. We're talking about unit testing right now, but yeah, having frequent bugs is definitely a sign that, the whole point of testing is to reduce bugs. Okay. All right, so let's go ahead and let's see what we can do. So before we start actually doing this, I'm going to talk about testing frameworks. So Jim mentioned, he's written tests before, but it's usually similar to what we've seen with the spec file, where it's something like, console log something equals whatever we expect. So that is a test, and it does work. But like anything else, testing is something that people do. So there are common sets of problems and solutions. So there are a number of different testing frameworks that people have come up with, and we're going to look at Jest. So you don't have to like Jest. Jest doesn't have to be your favorite. You're free to use something else, but we'll look at Jest. So Jest, I believe, is made by Facebook. So a lot of these frameworks that we have are, companies trying to solve their own internal problems, and they come up with these paradigms, and they kind of group things together, and sometimes they make that available as like a library or framework or whatever. And if you look at other testing frameworks, especially JavaScript testing frameworks, there are a bunch, and they all more or less do the same kinds of things. So we go to the documentation, and then it's a third-party package. So we're going to have to, let's go here, and I'm going to rename this. I'm going to do old FizzBuzz. We're going to have a new FizzBuzz. So if I want to use a third-party node package, what do I have to do?
There we go to NPM.
Yeah. Can you guys see that I'm recording right now? Just to double check. Okay, cool.
Yes.
All right. So what should I do?
To the website, we
Knit.
downloaded that NPM website.
Okay. Yeah, so I could go to the npm, so npmjs.org, and I can do Jest. And I can take a look at stuff, and then they will refer me back to this website, which is basically right here. So yes, so especially if I'm looking for a new testing framework or something, I can go here. This is like kind of the source. But in this documentation, they tell me how to install it. So can I just run this command? npm install save dev jest.
We need to npm init first.
Yep. Yeah, so right now I don't have, this is not a node project, so I need to do that. So npm init, and I'm just going to do the -y flag so I don't have to answer those questions. So what did that command give me?
JSON package.
Yeah, package.json. So what is this?
It's like the configuration for the various packages that you'll need.
Yeah. Yes. So now that we have a package, let's go here and we'll run npm install save dev. So we don't have to use this flag, but does anyone know by chance what the save dev flag means or might mean?
It lists the package in a separate section of the configuration file, so that way if you don't need those packages in production, for example, the configuration file can be used to differentiate the two.
Exactly. So there are, let's say, two kinds of dependencies: a development dependency, which is something that like your code itself actually needs, and then there's a development dependency, which is just something that you need as you're developing the code. So it's kind of like meta. It's like a meta thing. So if you use a testing framework, your production code doesn't need the tests. Your development, like when you're developing, that's when you need the tests. So this will take a minute. And you can see that my package.json has changed. I have a new entry, dev dependencies, and it's telling me that Jest, this caret means a version greater than, so something greater than or equal to 26.6.3. So anyone else who uses, who wants to make the code that we're about to write work will need to install this if they want to run our tests. Okay. So now we have that installed. And then here we need to add, they're telling us that we need to change something in our package.json. So in test, right here, so by default, it has this. So let's run test right now. So npm run test. We see that this command is executed, error, no test specified. And then it exits 1, the exit status. So exiting with a 1 is an error. There's an error. So this is just bash. So we could change this, and then we run test. Now that obviously is like not expected thing. Like you wouldn't want to actually do this because you should be running actual tests when you do this. But all this is just, a terminal command. So here we're going to change that. We're going to follow the README, and this will say Jest. So Jest will know what to do, basically, at this point. So we'll npm run test, and we do that. It's like running Jest, and since we have Jest installed, at least in our local environment here, Jest will take over. So let's see what happens. Okay, we get still an error, but we get different error. And the error says no tests found. So we're gonna have to write some tests. So you can follow the documentation here. We'll start out by doing this. So this will be sum.js. And then we create another file called sum.test.js. We'll paste this in. Let's just run it and see what happens. Not quite sure what any of this does yet. That's fine. We'll just run it. Okay. So something happened. Looks like we have pass. Again, I don't know what any of this means because I haven't really read it yet, but something different has happened. So we followed the README. We have a function here. It looks like this is just something that adds two things together. Then we export that function. And then here in this whatever.test.js, we're importing that file, the sum. And then we have a function here called test. And how many parameters does test take?
It takes
None.
two parameters.
Two. So what are the two parameters?
A string and a function.
Yes. So a string, and then comma, and then a function. Is that clear to everyone? So it takes a function, and then we have something else, expect, and then what does expect take? Can someone help me understand like the basic structure of this line?
It looks like expect is a built-in function from this package.
Yep.
And it takes the function you're trying to test.
Mm-hmm.
And then .tobe is just a method it runs on it. So it's like what you expect the return value to be.
Yeah. Okay, so expect is a built-in, just like test, because we haven't defined test anywhere, right? So test is coming from Jest, just like expect is coming from Jest. Expect takes one, looks like it takes one parameter. It's possible that it could take more, but at least one, which is the function that we're interested in testing. And then after you call that, there's a method called tobe, and it looks like that's whatever you want this to be. So if we were writing this in a like naive test, we might do something like console.log sum 1, 2 triple equals 3. Why did we apply? Okay. So if this were, like a naive test, the way you've been writing in the spec files, that's what that would look like. But if we do it this way, we get all these cool colors and everything. Okay. So that's the basics. And if we wanted to learn more about the documentation, like what is this expect business? What is this test thing? What is this to be? We could go into the API. So here's the documentation, getting started. We could go through this. Looks like there's setup and tear down, mock functions. So we'll go to the API, which should have just all the stuff in it. And we can do Control F, and let's do 2B. So it looks like there's to be greater than, to be truthy. It looks like there's a whole bunch of similar kind of looking methods. Let's see if we can actually. Might not be in this file. Yeah. So we'll have to look elsewhere for 2B, but we can see a bunch of other stuff like, let's see if test, or what was the other one? Expect.
Yeah, it looks like there's a whole section on the left side, Nav.
Over here?
Yeah, for expect, I think 2B's in there. I think.
Cool. Yes, thank you. So there's documentation. You'll have to navigate the documentation, figure out where things are. But there's a whole bunch of other methods. So you can look at the expect. So here's the documentation. The expect function is used every time you want to test a value. You'll rarely call expect by itself. Instead, you'll use expect along with a matcher function. So that matcher function is this method right here. So we're calling expect, and then we want to compare it with something else. So here's an example, and then we can see all of these. Let's do 2B, to equal, to match, to be falsy, for example. To be falsy, when you don't care what a value is and you want to ensure a value is false in a Boolean context. So what's the difference between false and falsy?
False is exactly false. Falsy could be 0.
Yeah. So there are a few values in JavaScript that are falsy. Okay, so you can look at the documentation just if you want to familiarize yourself. So as you're writing tests, you'll kind of know what kinds of things you can use. All right, so that's the documentation for Jest, and we've got this set up. So now what we want to do is not just run this silly example, but run our own silly example of FizzBuzz. So I'm going to follow this pattern here, and I'm going to create a new FizzBuzz.js, and then I'm going to create a new FizzBuzz.test.js. All right, so I've got these two things. It looks like, so I can copy, I'll copy this for now. Put this into the FizzBuzz test, and then new FizzBuzz. Well, we could start by writing a function. So function, actually, let's just import our whole FizzBuzz function. Cool, and then we will const FizzBuzz require. And then we could do a test. I don't know, let's just say expect and then what kind of tests can we write for this function? Let me put these side by side.
Would you start with, does it return anything at all?
So what does FizzBuzz return?
Actually, it doesn't. It just console logs, doesn't it?
Does it return anything?
Undefined.
Yes, we could try that. So npm run test. Let me delete these. Try that again. Okay. So I'm going to go ahead and just add this. This may be cheating, just so you don't have to look at that error message again. Just so it doesn't, I don't look at the error message when it fails. Okay. So we ran, look at our output. You can see we have a test that I badly named It Works. And we can see that here. And this is the failing test. And we have type error. FB is not a function. So we have an issue with what?
Just the name of the function. We're just gonna change the name to
So,
it.
Yeah.
so what?
What's our FizzBuzz test in that document? Or our FizzBuzz function. So FizzBuzz, yeah, FizzBuzz.
Okay. Let's try that.
Is it because we're not exporting it?
Yes, it is because we're not exporting it. So module exports equals FizzBuzz. Okay. So now our test works. So we've set it up properly. So we have our export here, we're importing it here, and we're running this test. And then we run this function, pass it to, and it works. It does return undefined. So what other tests can we write?
We could include like some of the known expected outputs. So for example, if we did 3, 5, and 15, we would see FizzBuzz and FizzBuzz respectively.
Yeah. How do we check? How would we check those values?
You have to get to start returning something, right? 'Cause it's not gonna be able to check console logging, or maybe you can't read the documentation.
Yeah, so you can. We'll look at that in a sec. It's a little bit more difficult to do, but you can check the output of console. We'll have to use something called mocking. We'll have to basically mock console log. So this is one issue that I want to bring up. The way we've written this function right now, we're basically stuck. We can't really test it very well. So we can test that, the function exists and that it returns undefined. And that's basically it. We could mock, so we'll look at that in a sec. I don't want to do that right now, but we can mock console log, basically like kind of intercept console log. It's a little bit, again, it's more convoluted, so you can see that it's making it more complicated. And it's difficult to really get at what we're doing here. So we've written a function that works, at least we think it works based on the small number of tests we've written or we've done. But this is not really robust. This is not something that I would want to really depend on. So I'm going to go ahead and, I know it's painful, all of this hard work. I'm going to go ahead and delete this. And I think we should rethink the way we're designing this FizzBuzz solution. So we want to make a FizzBuzz that, you know, you can hang your hat on. 10 years later, someone can come look at FizzBuzz and it will still work, and they will know exactly how it works and why it works. So the first thing, Jeff mentioned this, but first thing we should probably be doing is returning values as much as possible rather than just console. So what, does anyone know what, maybe an unfair kind of vague question if you don't already know the answer, but there are kind of two categories of functions that do things like console log and functions that do things like return values. They don't happen to know. Again, that's probably a bad question to ask. So I'll just go ahead and say it. So console logging is something called a side effect. So a side effect is like, it's not, the function is changing something outside of itself. Console log, it might not seem that way, but what it's doing is it's changing standard output. So my Unix-based Mac here has standard output, and console log is using standard output. So it's actually changing something in my computer outside of itself. So this makes it an impure function. So there are pure functions. Pure functions don't change anything outside of themselves. They don't manipulate global state or anything like that. They don't make network requests. They don't log things to the console. And one reason why this is important is that it's important for testing, thinking about how are you going to design your application in such a way that it's testable or maximally testable. So if we're just doing a bunch of side effects, it's very difficult to test side effects. So what we want to do is return values and then test those return values, because it's very easy. If I give it, every time I give it a given input, it should always return the same output. So another term for this, again, don't worry about all the lingo, but it's called referential transparency, which means that it's almost like you have a it's like a 2-column spreadsheet, right? So I give my function 5 and it spits out 10. I give the function 6 and it spits out 12. I give the function, so it's almost like a lookup table. So your function could almost be expressed as a lookup table. Every time I give it this particular input, I can always expect this particular output. So you want your functions as much as possible to do this. Now, of course, in the real world, especially with web applications, you can't just have pure functions because you have to make network requests, you have to change the DOM, you have to respond to user input, and all that stuff is impure. But what you can do is you can kind of corral that impurity into a tighter grouping. So what I'd like to do is rewrite this. One, I want to break this up instead of, so this, our old FizzBuzz function. Sorry, does anyone have questions before I move on to the next part? Okay, so this function is actually doing a lot of different things. It's looping, it's checking values, and it's printing. So we can kind of break it up into those basic functions. It's kind of doing 3 different things. So one thing we can do is separate out, and only one of those is impure, right? It's only the console log that's impure. So this is the part that's hard to test. So what we can do is redesign and pull everything out. Let's try to break it up into three chunks. We'll have the, let's say, the conditional checks. That'll be one thing. Another thing will be let's say iterating, and another thing will be printing. So we'll have three different functions. So I'm going to call this value checker. So what we're going to do here is this will take in a number, and it should go through all of the checks that we've already written, so we're not going to have to rewrite that. And it'll just return whatever it's supposed to. So if I give it a 5, it'll return buzz. If I give it a 10, oh, if I give it a 9, it'll return fizz. If I give it a 1, it'll return 1, right? So let me just steal this.
Chad, on something like this, then we do console.log, we see it works, then we want to test it. Do we take all the console.logs out so it's clean code?
Yeah, so generally speaking, console logs is something you're going to want. I'm not saying you shouldn't console log. You should definitely console log as you're developing. But yeah, it's not something that you would want to leave in the production code. You don't want console logs everywhere. Let's do value checker. Okay, so now we have something, a new function here, right? Actually, I should probably have, if we're doing test server development, see, this is not something I do normally, but we should write the test first. So let's go ahead and pretend we didn't write this yet. So let's do value checker. Yeah, so we can do something like this. You can still keep that test. All right, so we have this value checker. It returns undefined, but it exists, so we're not getting an error when this is called. Let's write another test. And this time, let's try to check, for example, what data type do we want to return from this function?
I mean, integer, excuse me, an integer?
What about buzz and fizz?
So it'd be integer and a string?
We could write a function that would return either an integer or a string. Or we could just always return a string. Since, the ultimately what we're going to be doing is, displaying something. So it's going to end up being a string. Anyway, so we could do value checker returns string. And how do we check if it returns a string?
We use the type of method.
Okay. And then let's try running this. Okay, and our test failed. So this is what we want to happen, right? If we're doing red, green refactor, so we write a test that describes some functionality we want to have. We run the test, it fails because it's just returning undefined, which is not a string. So now we need to go back from our test, go over to our code, and write just enough code that the test passes. So we'll go ahead and and do this. So return, just return an empty string. Let's see what happens. Okay, so this most recent test passed, but now this test fails. So we started with one idea and we are developing it, and now we realize that this isn't going to work. So we can either change this, or we can look in the documentation. Let's do something like maybe this, to have been called. Let's try that. This is for a mock function. Let's try it. Let's try it.
Chad, how did you know to choose to have been called?
I didn't, and in fact, I think it's wrong because I think it's for mocks. Yeah. So we'll look at mocks in a second. I don't know if there's a. I'm trying to salvage the first test. You might just get rid of it. It's like to not be null or something. Anyway.
To be defined.
Could be to be. Where are you seeing that?
It was you scroll up on the.
Okay. Cool.
Oh, yeah, there you go.
Take the variable is not undefined. Okay. Yeah. Let's do that. To be defined. All right, cool. So now we have 2 tests that pass. So this returns something, like basically anything at all. This returns a string. And then we could keep going. So let's do test. Value checker. Let's see. Value checker 1 returns 1. Something like this. And then this should just give us the string 1. So we write this test, so red, green, refactor. So we write the test with some additional functionality that we want. We run the test, it fails. And so then we come here and then we write just enough to make this pass. So we're starting to have a problem now where we could do something like, we could have a conditional like if num equals 1, then return 1, else return empty string. And we kind of go, but I'm going to skip a couple steps here just for the interest of time. And we can go ahead and I'll just go ahead and put this in here.
So Chad, could you change the function and make it value checker num comma str?
I'm sorry, can you say that one more time?
If you change the function to value checker parentheses num comma str, would that help with the test? Things, the string seems to be what's holding us up.
So we could, if you want to do something like this, like.
Yeah, would that help the test find the string that we were having trouble with?
Well, so I don't know that we would want to add an additional parameter because we just want someone to say, give our function 10 and then print out FizzBuzz from 1 to 10. So if we had an additional parameter, I'm not sure how that would be used exactly, but here we're the issue before was that we got to the point where we had to start actually implementing logic in our application. And I wanted to skip a few steps because we'll be here for another hour if I actually do it one piece at a time. I'm just trying to skip ahead a little bit, which is, you know, always this temptation in test-driven development. So I'm going to run this test again. Okay, so we get some failures. So let's look at all of those failures. Okay, so I is not defined. Okay, so why is this happening?
Got to replace I with num.
Yes. So just blindly copying and pasting doesn't always work out. All right, so save this. Let's try running it again. Okay, so one passes. We've got an issue though. So why are these other two tests failing?
I think we need to convert num to a string in the return statement.
Right. Do you happen to know how we can do that?
To string? I'm not sure.
Yep. There's a couple ways you can do it. One of them is string. So let's try that. Okay, and now our tests are passing. So, you know, again, I think we just see a small example of why it can be useful. Even though we only have 3 tests, we were able to kind of get our code back up to speed, kind of where we left off. So we have that. That's like documentation, basically. It preserves the state or the, you know, how our application should be. All right. Then we can write. Is there a question? Okay. So let's write another test, something like value checker 3 returns is. I'll run this test. Returns.
I think the issue.
Oh,
yeah.
yes, thank you. Okay, and I'll just add a couple more for the sake of thoroughness. But so ideally, we should have been working up to this. But I'm cheating.
Same thing where it's still calling on 3.
Ah, geez. All right. Cool. So now all of our tests are passing. We have a bunch of tests. Of course, we could add more, and we're not even dealing with like edge cases or you know, user input, which we should be if this were, you know, an actual production application. So we're still you know, skipping some parts, but okay. So we have this basic functionality. So now, before, with our original version of our old FizzBuzz, we could really only run one test to see if the function existed, basically. Now, there's a whole bunch of other tests. We can test all of this different kinds of input. So that's good. I'm pretty confident. We could always add more tests here, but I'm pretty confident now that the value checker function works. But we need more than just the value checker. So we're going to need, let's do, this is going to have to iterate. So let's do something. get values. And that will take in a num as well. And let's see here. All right, so I'm gonna copy this line just for the sake of time. All right, so what I want get values to do, I'll show. There's a a lot of ways we could handle this. I'm just going to show you one way, but what we're going to do is we want to make an array that has the length of whatever we're passing in, basically. So create just an array of like dummy values or values from 1 to whatever number. We create an array, and then we're going to map over that array and call the value checker function for every one of those. So at the end, we'll start with an array of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll map over that array. And we should end up with an array that goes 1, 2, fizz, 4, buzz, and so on. So let's do we don't need to worry too much about what this function is doing. So I'm just creating basically an array of values to go from 1 to whatever this number is, basically. And then from there, I'm going to map over it. So that map, and then that will be, what is this called? Value checker. And then I'm going to return the mapped initial. Okay, so what I've just done, of course, I'm not doing test-driven development very well because I'm writing stuff, but these things always take a lot of time. So let's write another test here. So we'll do get value. Get values, whatever it returns, and array.
Do you need to export get values as well?
Yep. So this is a little tricky when we're exporting more than one thing, but you can do that here and get values. We're going to have to change this. So what I'm going to do here is, just to make things a little easier, I'm just going to name these functions so I can preserve, so I don't have to rewrite all this stuff. So I'm just importing basically everything in the file, but now I have 2 functions, so I can't just assume the default. So I have to specify. You can try running this just to make sure nothing immediately broke. Okay. So now we have to actually write this test. So GV. So testing for an array. So what happens if we do type of GV1, 2B, something like that. So we did something very similar up here. right? Type of whatever to be string. So this should work, right? Let's try that. So what's happening here?
The type being returned
Just
as
use
an object.
Why is it an object? It's returning an array. Why is it telling me that it's an object?
Doesn't JavaScript like everything is objects?
Yeah, except this one works. The answer is it's the vagaries of JavaScript. So an array is an object. There is no special specific type array, at least when you use this type of operator. So there's something else you have to do to test if it's an array. So array dot is array, conveniently named function, and we'll test it if it's true. So we're going to test if this function, this get values, returns an array. And it looks like it does. So it turns an array, and let's test something else. So it returns an array of length 1. So we'll do dot length, something like that. That failed. Expected 1, received 2. Yeah, so I think there's an issue because I'm counting 0 here. Let me console log. Let's see.
Actually, I think it's because the number being passed in is 1, and then it's adding 1 to that 1.
It's adding 1 to the 1.
Length colon num plus 1.
Yeah. So let me just double check, because I wrote this line assuming that we were testing for 0. So FizzBuzz and 1. So it's checking 0. I'm just going to do a quick check here to ignore. Let's see. Let me see. Something. So if let's see. I think I'm still going to get undefined there. Let's see. Yeah, undefined. I could do another filter. Let me do that. Okay, so this is not the cleanest thing, but it'll work for now. So can anyone tell me about what's happening on this line?
So the map is calling the value checker function on every value in the initial array.
Okay.
And then the filter is basically telling it to it'll return an array that includes all the values that match the specification that's passed to the filter.
Yeah. So if whatever you put here evaluates to true, then it will stay in the array. If it evaluates to false, then it will get removed from the array. So again, this is not the best way to do this, but it's what I can think of off the top of my head right now. So it'll work. All right, so now this test works, and we could, again, write some more similar kinds of tests. We could test the length, we could test specific values and everything. So one thing I want to note is that, we have all these tests, so this is starting to get a little bit hard to follow, just a whole bunch of tests. So it might be good to impose some more structure. We're kind of testing two different things, right? We have one function here, we have another function here. So we can actually do that with describes. There are layers. If you look in the documentation, there's not just the test functions, but there's a describe function, which you can wrap around a bunch of tests. So we'll do this. And describe, like test, we'll take a string, and we'll call this the and it will pass a function, or take a function. And we're going to just put all of these tests right in here. And we'll do the same thing here. All right, so what? One sec, let me check. Am I still recording? Yeah, okay.
Yep.
Just said I was logged in from another device. All right, so so now I haven't there's a little bit more structure here. So this describe thing, you can also do other things. We won't go into it, but you can do things like set up default values and so on in here. But here we just divide this up. So now if we run, let's see. Describe. Let's see here. Describe. Just comment this out. Describe. expected string. Sorry, one sec here.
I think you might be missing a close brace. I think the close brace that's not commented out is,
This is here. So this, the open brace there, then the closed parentheses there, and this one here. So I think those match. This may be my VS Code helping me by not helping me. Yeah, so when I added describe, I got an auto import, which was the wrong one. So thank you, VS Code. All right. So we're back to where we were, except now we have a little bit more structure. So we have these describe statements. Okay, so we're going to add one more function, which is going to be our printing. So let's call it like that, and it will take an array. Let's see, an array of values, and we'll just print it out. So values are join the space and all right. So what we've done here, the basic process is we've pulled out, we've kind of isolated our side effect, right? So now we can thoroughly test every other part of this application. Instead of having one function, now we have three, and we can thoroughly test all parts of it. But we still have this last part, which is a little tricky, this side effect that we want to test. There is a way to do that. There's a couple ways to do that using something called a mock. So let me copy this. All right. So mocks are a little bit complicated. You don't necessarily, if you can get away without doing that right now. But you can go into the mock functions here and take a look. I'm just going to go ahead and show you what I already have prepared because I don't necessarily want to take a lot of time. But what you have to do, because console log is a side effect, you have to basically trick your code into not running the actual this actual console log. So we're going to substitute in a different function for console log. So it won't actually do the console log. And this is a common thing you're going to have to do with testing side effects, like a network API call or a database, accessing a database or whatever. So you kind of trick your code into thinking that it's done. So you don't have to actually have a connection to the database in order to run your unit tests. So this is, one reason why you want to minimize side effects, because it makes testing harder. All right, so let's do something like that. And we have to do something a little different here. So before we actually run our test, what we're gonna have to do is trick. There are a few ways to do this. So I'm gonna do it this way, where I just globally change console log. We could also inject it into the function, but we'll do it this way so we don't have to modify our actual code. So what we're doing here is basically saying, when we roll this, when we run this test, console, so global is like the global object in Node. It's the biggest, it's like the window object in the browser. So we're saying Node's console.log, we're going to reassign it. So just like any other function, right? We can have a function and then we can assign it to another variable. That's exactly what we're doing here. So anytime while this test is running, you call console.log, you're actually going to be running this mock console, which is this built-in Jest mock function. And then what we're going to do here is, first off, we need to import this. And then we're going to call the function here. Actually, we'll call it, and we'll call it with some arguments. So we're calling this function right here, and this is going to get passed the values array, which if we passed in 3 would be 1, 2 fizz. And then we're going to check, we're going to examine this mock object. So you do something, there are a number of things we can check. So expect mock console dot mock dot calls dot length. So this will check if this function has been called, the number of times it's been called. So let's try running this. Received 3.
So because it's console logging in the other function in our new FizzBuzz.
Oh, thank you.
So in our get values function, there's a console log in there.
Get values. Enter. Let's try this one more time. Okay, thank you. So, so this works, and there you can look at the documentation for more on mocks and the things the properties you can access here. You can also access the specific values as well, but you can see that this is a lot harder to do, and it feels a little janky. Or like we have to trick our code into not using the actual console log, and that's the only way that we can access this value. So this is what happens when you end up testing side effects, is you have to fake it, basically. So you want to minimize the places in your code. You want to like concentrate or pull out all the places where you're doing side effects and keep that separate. So are there any, I know that was very long. So are there any questions?
What other side effects would have been in that code besides console.log?
This is the only side effect. So we're not changing we're not changing any global variables or anything like that. So the only side effect is console logging. Okay, any questions?
When you did your FizzBuzz in the interview, did you do all this or did you just write the straight code that we did the first time?
Oh, I just wrote the code we did the first time.
This is going to take a lot of practice